Start of chapter 2. Chapter 2, section 1 is all about writing and interpreting equations. Later on in this chapter, we'll actually get into solving equations, which hopefully you guys have done a little bit of that in the past, but we'll deal with that when we get there. Today, we're just writing and interpreting equations. So, a mathematical statement that contains two expressions and an equal sign, there's what an equal sign looks like if you didn't know that, is an equation. So, if something does not have an equation or an equal sign, it's not considered an equation. So, chapter 1, we didn't really deal with any equations. We just dealt with expressions. If I have two expressions and an equal sign, that's when it changes to an equation. So, key concept when writing equations. Step 1, we want to identify each unknown and assign a variable to it. Step 2, we want to identify the givens and their relationships. Step 3, we want to write the sentence as an equation. So we'll use those steps whenever we're writing equations. Am I good to move on? No. Remember, all these notes are directly from the textbook. We're on page 65 in the textbook if you'd like to follow along. I do probably need to go ahead and get to the next slide for time's sake. So like I said, you can get the rest of this from the textbook. I am recording this, so if you want to get it later from Canvas, you can as well. But let's go ahead and move on. Okay, so example 1, write an equation for a sentence. So, it gives us a sentence, a verbal expression, and it wants us to write it out in mathematical symbols. 20 minus the quotient of 7 and x is the same as twice x. 20 minus the quotient of 7 and x is the same as twice x. So, it wants us to take the sentence and write it as an equation. Someone want to help me out on this one? Very similar to what we did in chapter 1. It's just adding an equation to it instead of just an expression. What does minus mean? Subtraction. So I've got 20 minus the quotient of 7 and x. What does quotient mean? Division. There's a couple ways to represent division. I'm going to use our fraction method to represent it. The quotient of 7 and x. So this is the division problem of 7 and x. Doing 20 minus that quotient of 7 and x. What do you think I'm going to put for is the same as? Equals. Yeah, very good. And then what would twice x look like?
X squared.
Not x squared. 2x. And there would be my equation. So, is the same as, that's going to be my equal sign. An equal sign means that the left expression is the same as the right expression. They're equal. They're equivalent. They're the same as. Those are some key phrases you might hear or see for an equal sign. Everyone okay with that? Questions on example 1? Can I move on?
Yes.
Give you a few more seconds. Okay. Example 2. Nice little word problem for you guys. I know you guys love word problems. Of 799 teens surveyed about what they do online, some use a social network. Of those on a social network, 430 say people their age are mostly kind online, and the remaining 193 do not. Write an equation to find the number of teens surveyed who are not on a social network. So we're going to kind of go through these steps of writing an equation from this word problem. We're going to identify each of our unknowns and assign a variable to it. Identify the givens and their relationships, and then write the sentence as an equation. So, Step one. What is or are my unknowns? What are they asking me to find here?
The number of teens surveyed who are not on a social network.
Yeah, that's that last sentence right there, right? I want to find the number of teens surveyed who are not on a social network. So that's my unknown that I'm trying to find. I need to assign it a variable. What do you guys want to use as the variable here?
X.
G.
X. I heard X first. So X equals number of teens not on a social network. Are we okay with that? Is that the only thing it's wanting me to find?
No. Wait.
Yeah, that's the only thing it's asking me to find, right? So that's the only unknown I'm going to have right now. Excuse me. Step 2, we want to identify the givens and their relationships. So what all information am I given? What about 799 teens?
Survey.
Yeah, there was a total of 799 teens surveyed, right? What else? What other information am I given?
430 people say that they're kind.
430 people. 430 say people their age are mostly kind online. What else?
And 133 do not.
193 do not. Is that all the information I'm given? Yeah, that's all the information I'm given. So, I've identified my unknowns. That's step 1. Step 2, I've identified my givens and their relationships. Step 3, we want to write the sentence as an equation. So what's the relationship between this 430 and this 193? What's the relationship between the 430 people and the 193 people that it's talking about? They're all online, right? Or they use a social network, right? So, for my equation over here, we got 430, 93, 799. So this 430 and this 93 are representing the people that use a social network, right? So I'm going to add those two numbers. What else do I need to add to this to get to my grand total of people that were surveyed? Now I'm going to be adding something because I'm trying to get the total number of people surveyed.
193.
Not 193. What's my unknown?
X.
X, right? That's the number of teens not on a social network. So the people surveyed, the teens surveyed, 430 plus 193 are on a social network. And then this X are representing the teens that are not on a social network. Right? So 430 plus 93 plus X is going to equal what?
It's not 192.
Oh, my bad. There we go. Thank you for correcting that. What is all of that going to equal? Not 623. How many total people were surveyed? 799. So I need the total amount of people using a social network plus the total number of people not using a social network to be equal to the total number of people surveyed. Does that make sense? Now, I can see here, well, that's all it asks me to do is write my equation, right? Does it tell me to solve my equation?
No.
No. Have I created my equation here? Yes. In future lessons, we'll get to the point where we will actually write this equation and then we'll actually solve it to find the unknown. Okay? But for today, it just wants us to write the equation. Are there any questions how I got to this equation? I want my total number to add up to 799 because that's how many people were surveyed. It gives me these two numbers of 430 and 193. That's the number of people on the social network. I need to add the number of people not on the social network to that. That'll give me my grand total of 799. Questions on example 2? Okay. Example 3. Write an equation with multiple variables. Translate the sentence into a formula. The perimeter of a rectangle is twice the sum of the length and the width. The perimeter of a rectangle is twice the sum of the length and the width. So we're going to kind of follow these same steps for writing an equation. Step 1, identify each unknown and assign a variable to it. So what's unknown here? Say it again.
Length and width.
Length and width. What else? What?
Rectangle.
Perimeter, right? I don't know the perimeter of the rectangle. I don't know the length of the rectangle. And I don't know the width of the rectangle. All those are unknown. So I need to assign variables to all of those. Okay? In math, most of the time we use P as the variable for perimeter, but we can pick any variable we want here. What do you guys want perimeter to equal?
T.
P? It's usually a capital P as well. In math, most of the time when we're dealing with a formula here, we usually let length equal the variable L. So we can do that, or we can pick a different variable. What do you guys want to do? L. I usually make it a cursive L so it doesn't look like a 1. And what do you think width usually represents? W. So, I've assigned each unknown a variable. Correct? Okay. Now let's kind of put it all together as an equation, or as a formula in this case. So, the perimeter of a rectangle is twice the sum of the length and the width. Any ideas what that's going to look like as an equation? Anyone want to take a shot at it? Anyone want to take a shot at this? Well, let's just read it and write it out as we're going. The perimeter of a rectangle, what are we using to represent perimeter?
T.
P. So P is, what do you think I'm going to use for the word is?
What? Is.
What symbol do you think I'm going to use for the word is?
Times.
Not times. Equals. If I said like x is 3, you could write it out as x equals 3, right? It's kind of the same as, that's another key phrase, just like is the same as. You might see equals as just is. So the perimeter of a rectangle is equals, what does that twice look like? 2 times something, right? Not something squared, but 2 times something. So twice the sum, what does sum mean? Add, right? So 2 times the addition problem of the length and the width. So what would that look like on the right side of this equation?
2 plus.
Not 2 plus. Remember, twice is doing 2 times something, right?
Multiplication.
multiplication. See what's that going to look like here? If I'm doing twice the sum of the length and the width.
2L plus W.
You're very, very close. I'm missing something from this. Say it again. I could write it out like that, but I want it to represent exactly what this sentence is saying. So I actually need parentheses around my sum here, because it's saying twice of that whole sum. So I need to multiply 2 times the sum of my length and width. Does that make sense?
Yes, sir.
So here is my formula for the perimeter of a rectangle. It is 2 times, twice the sum of the length and the width. Any questions on that? Questions on example 3? Okay, can I move on? You don't necessarily have to write this information down. It is in the textbook. Just make sure you're paying attention. Look for the relationships in an equation by interpreting each part of the expressions in the equation. As you interpret an equation that represents a real-life situation, consider that the equation may be viewed as a constraint in the situation. In mathematics, a constraint is a condition that a solution must satisfy. These conditions limit the number of possible solutions. The solutions of the equation meet the constraints of the problem. So, an example of this, in math, we cannot have 0 in the denominator of a fraction. So sometimes, later on in upper level maths, you'll get a variable in the denominator of a fraction, and a constraint on that would be x cannot equal -3 because that would give me 0 in the denominator. So that limits my solutions, like it says, because x can't equal -3. That takes away one of my solutions. So that's what this constraint is talking about right here. Okay. Example 4. I've got 2 more examples for you, then I'm done. Write a sentence for the equation. So this time we're going backwards from what we just did. Earlier it gave us a sentence and we wrote an equation from the sentence. Now it gives us an equation and we want to write a sentence for the equation. So, is there going to be one correct answer here? No, because there's multiple phrases for subtraction, for multiplication, for division, for the equal sign. There's all sorts of different phrases for all this. So, it may not be, there's going to be multiple ways we could write this. So, 2z minus 1 equals 5. 2z minus 1 equals 5. Let's just take it step by step. Let's talk about this first term here. 2z. How would you want to write that out as a sentence? Keep in mind, you could use something similar to what they did here. Twice the sum. You could do 2 times z. What do you guys want to do? Twice. Twice what? Twice z. Okay. We've got this minus sign here. What do you guys want to use to represent this minus sign?
Minus?
Yeah, you can just write minus. Twice z minus 1. There's really only one way to write the number 1. Twice z minus 1. What phrase or word do you guys want to use to represent this equal sign? Is. And then 5. Everyone okay with that? Twice z minus 1 is 5. Or you could say is the same as 5. Or equals 5. You could write the word equals out. Any of those phrases would work. Like I said, there's multiple ways you could write this out. Does everyone agree with what we've done on this one, though?
Yes,
Twice z minus 1 is 5. Questions on example 4?
No.
Sweet. Last example. Write a sentence for the equation. 3 times y plus 1 in parentheses equals 12. 3 times y plus 1 equals 12. So, how do we want to write this one out?
3 times the sum of y plus 1 is the same as 12.
There we go. 3 times the sum of y plus 1. What'd you say after that? I'm sorry.
Y plus 1 is the same as 12.
Is the same as 12. Does everyone agree with that?
Yes.
I agree with that as well. Some other variations you could have used here. Instead of saying the sum of y plus 1, you could have said 3 times the quantity of y plus 1. 3 times the quantity of the sum of y and 1. You could do multiple different things for that set of parentheses there. Is the same as, equals 12, is 12. You could use multiple variations for that equal sign as well. Are there any questions on example 5? Any questions on any of the notes we just took? You all right? Okay. Your assignment's online. Again, just like you guys love to do. It'll be 2.1, homework number 1, MH. I've got to go make sure that that's published. So are there any questions about the notes before I end the recording?